I shall continue. Target is it stated? Log tag till test delete. No, test type info. Tag type info. No. These are just the TST ones. Now loop over that and then add a library. It's not a library. Oh, it's a library. It wants to make a library. Yeah, I guess I have to combine it with... No, not really. This is just an intermediate object directory. So we could have known this. Let's look at this shared thing then. So this thing printed what? Oh, it is already shared behind it. No, weird. Yeah, I don't want to do this. Let's just add an executable. Right. Well, then what is the difference with the other things that they have? Threads is threads. Thread, oh, shared libs. Threaded shared libs. No. Difficult stuff. This is not correct. Yeah, it's not a target anymore, right? Let's call it this name then. Yeah, let's see what is missing. No, that made lots of stuff. I think all of them. Alloc tag till type info shared. Let's see if I can make them. That still doesn't work. What is it trying to do here? Is it trying to build all of them? Yeah, it tries to build all of them. Basic.cc. Basic.cc. So that would be basic test. I think that I want that to exist there, so I should be able to do make test basic shared. Yay! Brilliant. Except, well, I can't find config.h. I think that's in the object directory. Probably. Well, maybe in testsuite. Nope. Find anywhere in the object directory. Name config.h. I was not looking correctly because it's just there. Yeah, here it is. So I need to add the object directory. Top level binary directory to the include path for all of these things. Not the current binary thing, but this one. That's the top level. Include directories. Maybe this one as well. There is a config even in there, so. Maybe it's that one that I need. I don't know which one I need actually. There's two configs. Target include directories. Target include directories called with invalid arguments. Nice that you show those arguments. Now it worked. Oh, why would I not have aliases for this? Oh, because I have to run it from a script, I think. Yeah, I can't just run it. I think normally I would do something like... Oh yeah, forget it. You cannot run it directly. How does that work? So we can compile this thing, but... Yeah, that is the target. But then there is no running it from here. Of course there's running. So like literally a run, I think. But is that the only way that I can run it? I cannot remember that. Run test. For in echo, set a library path. It does just run it. It does. It just runs it, except for setting a library path to dot. That's to read the module underscore R. So that's also not needed. I'll just tell cmake that I want to link with that. This has a for loop. It's kind of weird. It doesn't even change the directory. So where would that be? Where would that thing be? In the current object directory, current binary directory, I mean. Can I run it from here with a relative path? Bullshit. File. On 3D. Yeah, that links with something, but actually that is the current build directory as well. So it does link with the correct library that exists. It's the date of today. A long time ago. Let's see if that compiles. That is the top source directory. Only there's a no debug.h. And that one is required for the target test location shared at the very least. Maybe others as well, I don't know. Let's add it here. Current source directory or something. Current source dir. Yeah, it is green. That must be good. Now what? Okay, that's definitely confusing. Failed tstcf shared. Why? Where's my error? It looks like it's not linking with libcwd at all. I think this one or path something should be in there then. Huh? What is highly weird? But just link errors. No, yeah, in the end it compiled with that. Without errors, it seems. Yep. Well, at least fix that then, huh? Right. Adding an include for the object there and the current. This is the source, yeah, current source directory. And I have no idea why I included it because there is nothing in it. I meant the top. Did I not mean the top? Yeah, that includes macros. So when I first called an error about no existing macros, then why does it exist now? Oh, because it was dot macros. I think the reason for the dot macros is simply because I expect to have an include dot everywhere. And yeah, it was missing. Well then, I might as well include that. Well, everywhere, which means that, yeah, well, we're already there. So there's nothing in here. I don't know. Let's just try to get the linking working, I guess. And then we'll see if there are any compile errors. Why is it not linking? It should be linking because of linking with that here. Oh, it also linked, of course. Yeah, so that exists. So a few things were compiled. It's so weird. I can assume that I included the wrong config and that is the reason. I'll just try that, I suppose, because I have no other idea. So I added an include directory, the top build directory here, in order to pick up a config. Top build directory that has a config, but that's not the one that I want apparently. There's also one in include libcwd. Yeah, maybe that's the one I want then. Let's try that. Make location shared also compiles. Oh, that doesn't work. Output. Nope, also not. That was recently compiled. That's nonsense. Totally nonsense. Never mind. Oh. I think this did not exist. Yeah, well, I listed it. Not just listed here. So it did exist. And I have no idea what just happened. Okay, now it's happy. It prints basic test, so we have a sort of a lift off. I'm going to try and make clean here. Cleaning 62 files. Yep. Let's see what is now in the object directory. Does that look clean to you? Yeah, these generated files are not removed. Mm. I'm also doing effort for that here, I think. I have a clean. Not really. No .h files here. Maintain a clean, dear clean. SVN. Oh no. That's the wrong directory. That's what it is. It's mentioned as build sources. And then dist clean files, build sources. So it's kind of supported for autotools that way. So when is this run? It's already the root. To do shear clean. Oh yeah, real clean, phony, maintainer clean, extra. So this target, wherever it is, should be calling that one, right? Who defined this maintainer clean then? Custom command. So maintainer clean must also be here in the root. Maybe I added it in CWM4. Cmake maintainer clean. Yes, there it is. So that is already built into my system. Maybe I can do real clean is running target clean on build. What is this? Let's see if they exist. Real clean or maintainer clean. Very, very, very clean, I have to say. Yes. It even updated stuff, so clean it is. But what did it remove? Well, it existed, let's put it that way. Generate build files. Run maintainer clean. Running maintainer clean extra. Ta-da! Build target maintainer clean extra. The only downside is that after that, I think it runs autogen.sh, but it should not have generated anything new. That's pretty clean. There's still a tiny little bit left. This is also a generated file. Pretty sure of that. And these two. And then Ninja depths, yeah. I wasn't aware of Ninja existing the moment I wrote these clean targets, I think. So what is mostly missing here is an extra clean target for the generated cmake stuff, which is also too new, and that one. just .pc. Also not. Weird. Oh shit. I'm not in the root. There we are. The file was called _r. So it's generated from this one. You would say that that just mentioned just like that, and it is here. Config file. Now I have others, and these are removed, and that is because they are mentioned here. Doesn't allow me to do that. Well, then I'll add it to the other one. Let's first test if it works. Just to find what? That's not clean at all. That is not cleaned at all. So even object files are left. And the config files. Other object files, not clean. Everything is still there. Shit. Do I have to run a make clean separately or something? Oh wait, yeah, no rule to make target and maintainer clean. Where does that come from? Thought it could totally work before. Yeah, maintainer clean. What did I type? Oh, eh? Okay, you can't do this when you didn't make clean, I guess. Or I'll have to compile first. Nevertheless, clean is not working at all anymore now. And this thing is still there, so it doesn't work at all. No, it's complete bullshit. I don't get this. I hate this. Okay, let's fix the rest. No, doesn't know assist H's. For which target? Demangle 3. It's just compiling libcwd itself. So where does that come from? I never even changed this. Got to run configure first, okay. Now everything is compiling. And then yeah. Looks like it should be loading this now. Lib module underscore R. Only those two? Deal open and filter. Undefined symbol. DWARF private free list initialize. Can I put that here or? Yep. Now, why would that be? Just guessing something. Probably not correct. Object directory. Where is that? Not here. Maybe there. Maybe well, maybe here. That's object directory. Plug it. Crap. No, nobody knows. We do have a lot of stuff here, but no free list. Find .f execute crap free list. Why is this taking forever? Oh. Valgrind sub. Seriously? It should be part of the library. So I guess it's if dev'd out or something. You can even see it in there already. Initialize TS, that must be defined at all times. But then you would think that if this is not defined, then we have that one. just initialize. I didn't see that in the symbols either. I didn't see any free list. Read elf, loads of stuff, but no free list whatsoever. There is a TSD, so it's really the missing of the free list thing. Why? Private allocator, free list. What's the use then? No. Okay, so initialize is defined. Not there. It's not defined. In the .cc or whatever the thing is called. Oh, it's not in include file. It's probably called cc, but I need it not include. Yep. Free list. Allocate. Deallocate. Uninitialize. Initialize. This is the one. This is the one that we need. And if that is completely missing, then maybe I'm just missing the private allocator source file. Because I wouldn't have any other idea why that would be. Or this fails. If cwd alloc and alloc is not defined. No, it's not defined. That is then the reason. Why is alloc not defined? Well, because I turned it off. Okay. PE. Alloc is off. Therefore that file is empty, therefore it should never have been used, but it is being used. And it is used in by, well, it was not used by the basic thing. That works. So it was being used by one of the other things. The last one of the last ones. Deal open shared. No. No, I don't know. The demangler? No, that worked. It's an undefined symbol. Oh, no, I remember. I did run it like this. Okay, so it is deal open shared. Deal open shared is using something. DL open. Why? Oh, I get it. Yeah, it was in the library that we allowed, so it's not here. The library target, the C module thing. Or is that defined? Module. Undefined, that it's using the free list. Why? So module.cc is somehow using the free list, but not directly. That there must be one of these headers here. Elk tag debug maybe. Either that one or that one. So we just remove everything here. Everything. No, wait a minute. Read elf, not returning anything. So it disappears if I comment this out. But yeah, this can be a matter of instantiation. They are back. No, that's either that thing or the impossible. Okay, so maybe it's just this one. I don't believe that, but okay, let's start from the top. Yeah, no, we don't have a static test symbol. Mm-hmm. Of course it's back. I think it's a matter of instantiation of something. With this commented out, it's not happening. So that would be libtag then. So now it should be there again, and it is. So that's then the other libtag. Basically it's just libtag, but the rest cannot be. The rest just has libtag as well. So let's say we comment out all the libtags, but not any code. Yep, no undefined stuff. libtag, what is libtag doing? Should not be doing anything because I disabled alloc. Oh no, empty lines. So so weird that this kind of thing pop up while if you switch build systems, then it just works. That's a lot. There's a defined for libtag. That could be it. No debug. Oh, that. Oh, look at that. Yeah. Testsuite. Loads and loads of libtag stuff. Macro libtag. That's probably the header, right? This is the one that is being used, however. Yeah, If define debug log, then define it. If it is not defined, log tag should be empty, and clearly it is not, because it's dragging stuff in with 3 lists and stuff. So either this is not included, or CW debug log is defined. Now in any rate we should never get here. So error DWARF tag is defined. Oops. Well, surprise. Definitely a surprise. Make clean, make no complete compilation. Impossible. Okay, so apparently we don't get here. Because this gives an error, so this is included, and if I put the error here, it never gives an error. So CW debug log is not defined, which means we include the correct config.h here. And log tag is defined as, well, empty. So we do get here. Except that we don't get there. Well, new trick. The trick is as follows. Apparently, while compiling module.cc, and it is so, -c that file, it has an log tag defined, and we don't understand where that comes from. Literally, I was thinking that I was pronouncing this sentence, and then halfway the sentence that was not true anymore. Because halfway the sentence I saw this and I thought, I do understand where it comes from. And then I thought, but let me just finish my sentence, otherwise it's so weird. And now I had to laugh. Okay, so yeah, well, the trick was anyway to do define, just put a define here, log tag foo, and then it will tell you where it is defined, because you cannot define it again when it is already defined. So, pip, op. Log tag redefined, previous definition, there. What? What? I never get it. That's unexpected. No, wait a minute. Oh, it is from log tag debug. Okay, it is from log tag debug. But yeah, okay. We'll have to look at this file, I suppose. Need to have a look at that file. What? Okay, I'm completely what is the word? Flabbergasted again. That's alloc tag. It's empty. So that maybe this is not true. Maybe you don't get here. I mean, really, it's already, should it not already have been defined? No, it's not. I have no clue, man. What the hell is going on? Well, let's first put a warning here then. Warning. Defining alloc tag to be empty. Aha. Aha. So that is the reason. We don't get here. Which means that CW alloc is not defined to 0, right? To be defined and to be defined to 0, but it isn't. This is my paranoia grep. Normally I use grep source and aliases, but this is just, well, I just want to search every file just to be 100% sure I don't miss it. That's too much. Let's include a define here. Define. I did not want defined. I just wanted that one, but that is no debug. And this is just a test. Example project. So the define must come from include libcwd config.h, and that's not included. Therefore, it is not defined at all, and that's a problem. And I never ever want to run into this again. So I'm going to add here if not defined alloc error config.h wasn't included. That didn't work for some reason. No error. So it is defined. Then what? Then what? 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 Okay, then the other trick. So I define it again. And I want it to be 0, but now it should complain. Already defined. But I want to explicitly just build module.scc. which was huh? Oh. Yeah, this one. That's a linking. We just want to do that one from that. Why did I not already have that? Copy. Already defined, previous defined, there. Why is there one? User include. A completely unrelated file is being included. Okay, now we have zoned in onto it. Now, of course, user include is kind of the logical thing to want to have in your include path. So what is really going on is that we are missing the include path of the real path, the real config, which is just missing for a module. It's just missing for a module. That's all. That's it. So this line here, that's the one that's needed to find that config, and that is missing from the module one. Module R, include directories. Yep. Okay, let's give that precedence, and then we need that one. Whew, that was a hard one. Yeah. Let's remove my warnings. I think now it compiled. Yeah, no error, so that's good. Maybe I should just run it before removing everything again. All right, I need this one. Yep, that works. Well, sort of. Doesn't work, but no errors. Yeah, I added it. That's all I can do. I should still get an error then because of this. How can it... Is that just a warning then? Or is it still not defined? Oh, that's the reason. It's not defined. Huh? I think I'm getting it. Yeah, so there's still a bug then. But let's start with restoring this one, and then what do we have further on? That one is good, I guess. This is good. The rest is good. Well, that's interesting. No, it doesn't compile anymore. Configure, make, oops, make, okay, that was it. Got to do your configure. No error. And we are back to the undefined symbol. Just define the 0 in that file, so if it is included. And what I changed was not defined, then I want an error. Didn't I? Didn't I? But which file was that? I didn't see it in the div. No, it must have been appeared in the div. So I probably accidentally restored it. That was that file. Yep. So if not def that, I just restored that. Stupid me. What the hell? Nothing works out. Just compiles. Okay, now again include testsuite libcwd test, include this ls that. There is a config.h there. Oh, it's including libcwd config, of course, somewhere. Yep. Really? Maybe. No. Really? I guess so. Unbelievable. Try that then. No, apparently not. Now it includes the right thing, yes. And it is now allocated to 0. Oh, okay. Pretend as if I never saw that. Boo-boo. So apparently you're supposed to cd here and then run that. The last one was that. Go to the next one. That one works. Where's my ls? Dude, I just did an ls. That's what we really want to test. So let's start here. Warning, DWARF version 5 is not understood by libcwd. So I guess we found our test case. And in the meantime, it's so late that I have to go to bed. But hey, we did crawl 1 millimeter forwards. And this objective to get this working. Yep, so that would be our test then. No. So this test calls recursively functions. This is being called from main. Which then calls test1, which calls test2, which calls test3. So we have a stack trace. And then test3 does gets built-in addresses, built-in return addresses, or we get it from the stored one, so we stored along on the call stack. And now we want to print where we were called from, which is done by creating a libcwd location class type from the return address plus some offset that might be needed. And then we do the check if it is correct. Guess frame return address, only return address. Just another something else. I don't know. Yep. So it's mainly the test is mainly about this. I think the constructor of location class type. It is defined here. Declared here. Suppose it's defined here then. Nope. Also not. Also not. There's an inline function. Dot inline. Nothing. No, just not colored. Here we see some stuff being filled in, albeit an unknown function in this case. Address, well, func is one thing. I guess I call all the members, and only the members will survive returning. M underscore. So although this is a pretty large function, it shouldn't be too hard to find where all that is defined. Okay, now I went too fast. What's the location class type? Assignment. There's also in file path, file name, and line. Those are the three things, and func and object. Well, might as well just jump to that. Class type, line, function, object file. Station delayed. Unknown, whatever, file name, points inside and file path just after the last slash. So that is just m file path then. And where is that defined? Oh, here, file path, the full source file name of this location, allocated in MPC location. unknown PC, and this is the address. Yeah. You would think that if I rip out everything, that I do not need that object file pointer. That's the only thing that I see that is extending this into unknown auto territory. So I don't want to keep it. This one, object file class type. Pointer to an object representing the library or executable. Why would I want to have that? I mean, if this is already defined, would we miss it after that it is defined anyway? Well, let's see what this is used then, I guess. It's part of the public API. Ugh. It has a meaning as a boolean. And again, object file equals 0 if object file equals 0 and mfunc points to as pre-iOS initialization constant or as pre-libcwd initialization constant, then this is the address that MPC location was called with. And the other one says if object file equals null and func points to unknown function, or this is the address. No, then this is the address that it was called with. And it's a union. So yeah, either we know the file name or we don't know the file name, in which case we only know the address that we were called with, if any. And if everything goes well, then we know the line number and we know the function, mangled function name. I guess a source file is then maybe part of this thing, because I don't see a source file. You can also look at the print on. So we want to print it, then print file path on, print file name on. Print location on. Yep, you print this thing, it calls print location on. So let's have a look at that. Okay, so the location is known, now we know everything. Otherwise, if at least we know the object file, then we print the name of the object file, as well as the function name, the mangled function name. Mangled function name. Otherwise, we don't know anything, but we can print the program counter. So what is this then? Of course, the name of the object file, but suppose we know everything. What we do then is same thing, just what we start with. Object file, file name. So that should be the source file name then, I guess. Yeah, or isn't it? Unclear. It's followed by the function. Just a different thing. Normally I have that all. This could be an .so name. So object file is printed if you want it to be printed. Could be the name of the executable, for example. Yeah. And then we print the function name and the mfile path. That's the source file name. Colon the line. What is the full path? Yeah. So we have the full path, or just the file name. So that points inside this one. Right, then I need to figure out how to initialize all of these variables. And in case of the object file, we only want to know the name of the object file, apparently. So So you have to look here as well then. File name, null, file name, yeah, that's it. It's not used for anything else than printing the file name. So this thing is containing file name, file path. Okay, I probably have to keep this one too then, I think. But from alloc list. Yep. But it's not, does not require changing, I think, because it's simply constructed from a file path, so I still have to find that. But then this object is simply constructed from the full path, and that's it. Do need to know though where this is then being constructed, or where the constructor is being called from. It happens when a B file is being constructed. It's a member of that. Yeah, this is stuff that I want to drop. Don't want to do anything with all of this anymore. So it's a bit unclear then where my object files come from. Okay, let's have a look. Object file class type. Who is all using that? Yep, this seems the only place then, yeah. It's just a member. And I think I have to delete all this file plus this file, just should be deleted. So deleting this file means that we don't have a B file anymore. The B file class. We also have structs here. We have a hardly a struct. Clause. Ding ding. Clause. Clause. Symbol. B file class type. that's it. It's at the bottom, some inline functions. This is my interpretation of reading ELF information. I think I have a, yeah, I don't know, symbols and stuff, and ELF and DWARF. So yes, basically it comes down to deleting that class, which means that. And of course bfd.cc. And that header file should go completely. No, it's only used in the ELF. So ELF is going to go as well. So we don't have a BFDST anymore. Symbol, section, whatever. That's the only place, so that would be, I don't know. ELF stuff. I guess anything namespace CWBFD has to go. Some stuff here. Look at this. Oh, it's just well, that's the thing came from that we are going to delete, so that's correct. What is this? Also an external reference. STInit. I guess that this is the initialization call that reads all the symbols then. So who's calling that? Yep. So only if we configure with location, and that's what this is on, this is called, and that initializes it. So this is the at least the place then where I want to do any initialization, if required. And I think it is required, otherwise we have to do the same thing over and over and over. So we do everything that we want to have to do only once here. Probably exists. This is where I would start to take notes. Because I can't remember that and I have to go to bed. Other things I said, delete BFD namespace. Oh, I forgot. Namespace that. Yeah, and that includes that class already, so I don't even need to mention that. The main API is location class type. and well, also I guess object file class type. Yeah, it's an API, but it's just not really, I don't know, it has to be initialized, sort of. At the moment you haven't. I could make a complete list of these things during initialization already. You need, yeah, definitely. Just read, yeah. You just read all the, we need all the addresses, start and end addresses of everything, of all the object files, so I might as well do that during initialization, and maybe even get a list of all the start and end addresses of the all functions as well. Depends on how fast it is. Yep. Maybe this is what I was working on here. Find function. I so should go to bed, but I really want to have a quick look at these new files here that I had already done. Yeah, that's nice. So initialize libdw, already did that. Then you can read address ranges. So those are the address ranges of all the object files, I think. And you can print them, or you get more info. So I believe that this is the way to deal with libdw. Not sure if this works, but I had made a beginning with it. So yeah, you can probably run that one. What is this? Usage elf file. Not sure if this is needed. Build ID. Yeah. A build ID. I vaguely remember that I did run into that. Whatever it is, I forgot. It was important for some reason. Oh, right. The build ID is, yeah, now I see it here as well. You need a build ID to find a separately stored debug symbols file. So, for example, on Arch Linux, those files are stored in mostly in this directory, sometimes in that directory with a .debug extension. So what I'm trying to do here is then also, you know, you get an object file, executable, whatever, and you see that, or library, and it doesn't have any debug symbols. And then you can read using elf the build ID and then construct a path and then see if there's a file there. And then read that file for the debug symbols. So it even becomes more sophisticated than it is than what I have now, with support for those external files. Yeah, I'm going to have to look into all of this again. Well, now I want to run it, of course. Build ID, does that still run? Elf file, well, okay. Is this an elf file? Yeah, found build ID. So that was one thing, and then we can do find function. What is that doing? Yeah, this is that you can DL address has support for function names, but only under very special conditions. So you have to, I don't know, normally DL address returns null. So this proves that. The instruction pointer is this, which translates to that relative to the beginning of the object file. So this is just the offset relative to the start. And then we can ask DL address for the function name, and it says, I don't know. And that's what you would get when, say, a NM tool doesn't return anything useful. And then we get smart to do sophisticated stuff. And then it says that is the name. So now we have the name. Ta-da! So clearly we have to be smart, because that is just not sufficient. Actually, this is the compilation unit. Well, I have the compilation unit, and this is the function name. So this is already very much working. I think I kind of already did it, now I remember. Except the integration with libcwd itself, which is what we looked at today. Now, one more. I had a resolve address. Now that prints source file line numbers with full path. Oh, it's a stack trace. No, find function is the latest one, or at least the last one that was changed. I'm going to go to bed. I'll have to continue tomorrow.